Let's talk about the greatest common factor, but let's throw in some variables because numbers aren't too bad, but what happens when we throw some variables in? Now, the greatest common factor is the largest number that divides evenly into a number. And that's the basics of it. But the one thing to remember is what happens when we have variables. So I want to talk about x to the third and x squared. So first of all, to have a greatest common factor, it has to be the exact same variable. And then if we think about it, x to the third is the same as x times x times x. X squared is x times x. So if we think about what is the most that we can take out of both, right? The shared piece. Well, we can take two x's out of each one. That means x squared is what we can take out, so that would be the GCF in terms of variables. The easy way to think about this is if we have the same base, the smaller exponent is always going to be the GCF. So if I have y to the 8th and y to the 6th, the GCF would be y to the 6th. Because y to the 8th, that means I have 8 y's, and y to the 6th means I have 6 y's, so I can take 6 y's out of each of those, right? Here I would be left with 2 because I've taken out 6 of them. That's the idea. All right, let's do a couple. We're going to find the GCF of 27x to the third and 18x. First things first, I'm going to talk about my numbers. 27 and 18. What is my greatest common factor? Well, if I want to list these out, 1 and 27, it's not even, so there's no 2, but I know 3 times 9, I can check 4, 5, 6, 7, 8. None of them. So those are the four for 27. For 18, I have 1 and 18. It's even, so 2 times 9. 3 times 6, no 4, no 5. Okay, so now checking these out, the greatest common factor is going to be 9. Okay, so I found my number portion. Now I'm comparing x to the third and x. As we just mentioned, right, if there's no exponent, it's automatically a 1. We want the smallest exponent. In this case, it's x to the first. So this would be the GCF of the variables. So then I would take the GCF of the numbers and the GCF of the variables, and that, my friends, is how we find the greatest common factor when we have variables and numbers together. Let's do another one. Find the GCF of 16xy squared and 10x to the third y to the third. Let's start with our numbers, 16 and 10. So for 16, I have 1 and 16, 2 and 8, and then 4 times 4. For 10, I have 1 and 10, 2 and 5. Greatest common factor is 2. All right, now let's go to our variables. I've got x and x to the third. It's the smaller exponent. And then I go to our y's. We have y squared and y to the third, and it's the smallest one. So when I put those three together, my GCF would be 2xy squared. Boom. That is the biggest factor I can take out of each one. And let's do one more. 6x to the third y squared z and 15xy cubed z to the fourth. Start with your numbers. I have 6 and I have 15. 1 and 6, 2 and 3. 6 shouldn't be too bad. It's a small number. For 15, I have 1 and 15. It's not even, so no 2. And then I have 3 and 5. That's it. So my GCF there is a 3. Then let's go to our x's. I have x to the third and x. Smallest exponent. And then I go to y squared and y to the third. Smallest exponent. And then I have z and z to the fourth. Smallest exponent. I am a visual learner, so I like to write things out like this. It makes my comparisons a lot easier. Now my GCF is 3x, y squared, z. I just put everything together, right? The GCF of each pair goes together. So 3x y squared z is the largest factor I can take out of each of these numbers. and that is finding the GCF when you have numbers and variables all together.